To reach the peak of a jagged mountain, cross a dense forest, or extract someone from an angry ocean, ground vehicles get stuck and airplanes fly past. These locations require a machine that can pull itself straight up into the air. This diagram shows the mechanical difference. An airplane relies on forward momentum across a massive stretch of open runway to generate lift under its wings. A helicopter creates its own lift by spinning its rotor blades, generating a precise, zero-footprint vertical lift vector. It can take off, land, and hover in place without forward space. Removing the runway requirement allows these aircraft to operate within the existing architecture and geography of a site. They can drop onto a hospital rooftop, touch down on the deck of a moving ship, or hover directly over a remote disaster zone. Because these environments are so varied, a single vehicle shape cannot succeed in all of them. To operate in such extreme locations, the physical design of the helicopter changes to fit the exact mission it was built to solve. The most common shape in the sky is the utility helicopter. This is a general-purpose workhorse, characterized by a balanced weight distribution, a medium-sized cabin, and sliding side doors. It is designed to carry small teams or loads of supplies across a wide range of everyday jobs. When the passenger count increases, that baseline design scales up into a transport helicopter. Engineers extend the fuselage and widen the side doors, optimizing the cabin to act as a high-capacity shuttle for moving groups of people into terrain where roads do not exist. When a job requires hauling heavy construction equipment or industrial materials, the design priorities shift. Internal cabin space is secondary to raw brute force lifting power. This logic diagram illustrates that transition. A standard transport helicopter is limited by the volume of its internal payload. A heavy-lift helicopter bypasses that constraint by using extreme bulk and often a second set of rotors to generate enough thrust to carry massive industrial weights on external hooks. As the logistical demands of a job scale up, the helicopter's design proportionally moves away from standard aerodynamics. Volume and raw vertical thrust take priority over all other features. In emergency response, the helicopter is reshaped to provide immediate medical care. A medical helicopter functions as a flying intensive care unit, prioritizing speed and specialized stretcher access over general cargo capacity. Search and rescue helicopters focus on extraction from dangerous terrain. These machines are outfitted with high-visibility markings, rescue hoists, and open side door positions that allow a crew to pull people directly from the ground or the water while the aircraft hovers. Another type of emergency responder targets environmental threats. Firefighting helicopters have the unique capability to track and suppress remote wildfires that are out of reach for traditional ground-based fire engines. Their entire structural layout is designed around an external payload of suspended water buckets or specialized internal tanks filled with fire retardant. This allows them to precisely drop suppression liquid to support ground crews. In life-saving missions, the machine functions as an active, hovering tool for intervention, performing rescue and medical work while remaining airborne. In dense cities, helicopters act as elevated vantage points. Police helicopters maintain an overhead view of a city grid by mounting external camera pods, infrared sensors, and high-intensity searchlights directly to the airframe. News helicopters operate in the same urban airspace, but use different equipment. They use heavily stabilized broadcast camera systems to beam high-definition video of traffic or breaking events from the sky. Far away from the city, offshore helicopters connect the mainland to isolated industrial sites. Because they fly long distances over open ocean to reach oil platforms and wind farms, they feature high-visibility paint schemes and specialized emergency flotation equipment. To learn how to fly these machines, pilots start in a training helicopter. These aircraft strip away heavy sensors and wide cabins, using small, simple frames with massive glass canopies to provide maximum visibility for the instructor and the student. Private helicopters use a similar lightweight approach, but prioritize sleek aerodynamics and interior comfort. These models offer a fast, efficient way for individuals to move point to point between urban rooftops or remote estates. Within the civilian sector, a helicopter's identity is defined by its external sensor packages and the fuel capacity required to reach its specific destination. Military environments force the most extreme structural modifications. The military utility helicopter is a ruggedized, multi-environment platform built with reinforced landing gear and an adaptable internal space for hauling personnel or supplies. When armed forces need to move heavy vehicles or massive pallets of equipment, they rely on military cargo helicopters. These feature wide rear ramps for quick loading and often utilize tanda rotors to generate the immense lift required for heavy transport. This frontal comparison shows what happens when cargo is no longer the priority. An attack helicopter takes the wide silhouette of a transport vehicle and compresses it into an ultra-narrow frontal profile. This design is built to house sensors and provides the smallest target from the front. Reconnaissance helicopters take a different approach. They rely on an exceptionally light airframe built for speed and observation, using advanced antennas and optics to scout terrain and relay information. In military applications, the requirements of survivability and sensory dominance force engineers to build these specialized structural extremes. Many specialized aircraft begin as a standard utility chassis. What makes them unique are the interchangeable mounting nodes. By swapping the components bolted to those nodes, attaching a motorized hoist, securing a water bucket, or integrating a camera pod, the aircraft's entire operational category changes. Every helicopter relies on the same core mechanical advantage, generating lift without a runway, allowing it to hover and access the most difficult locations on Earth. The helicopter is a foundational concept of access, engineered into hundreds of different forms to solve the specific requirements of the mission it is built to complete.